Okay, thank you, Brittany. So, hi everyone. So let's get started. Let me quickly introduce myself. So I'm Carlos Conde from the Technical Architecture and Evangelism team of Amazon Web Services in Europe. So I'm going to bring you in this session some customer case studies about European references on the topic of a second screen. And then Tiago from Magazine Luiza in Brazil is going to come to explain their own experience on how they build their mobile application with AWS. So just to make things straight, I have a quick definition of second screen. So to illustrate this, I want to share with you a statistic that was somehow impressive for us in Europe, is that 80% of TV viewers in the US are watching TV with a tablet or with a mobile device, right? So 80% is kind of huge of all the TV watchers. So you can argue that not a lot of people are watching TV now and so on, but still, I mean, for all those who are still there, the mobile device or the tablet is definitely now getting more importance compared to the traditional screen. Just to illustrate this, I wanted to show you a quick couple of examples of technical architectures that I've been working with and a couple of customers. The first one is VisiWare. So they are very well known in Europe and probably here as well, because they have been building the backend application for the game Who Wants to Be a Billionaire. So the point here is that during the TV show, you have exactly the same questions, and you receive the questions exactly at the same time as the players, right, in the TV, and you can play with them. So at the end, you have the score and so on. So here you can see that from a technical perspective, you have a couple of challenges, which is being exactly in sync with what's happening with the TV show. So a constraint that we're going to see in the other examples as well, and to receive the data and to be able to scale exactly at the right time. Because here, this is why you see so many second screen applications running on AWS. It's because just economically it makes sense, right? Because those guys from VisiWare, they're going to have a backend of their application running only one every 2 weeks for a couple of hours. That's it, right? So it would be completely silly to have a physical architecture for an application that runs such a low amount of time, right? And interestingly enough, they run their backend application in the European zone with multiple availability zones. For each TV show, it costs them less than $500 to run a backend application that sustains more than 5 million concurrent users, right? So another application they do is now they are exploring the field of media gamification for TV sports. What's interesting to see is that they pull out some statistics, and on the average, just 22 or to 25% of the American football games or soccer games are worth watching. The rest, they are completely boring, and that's the reason why people are watching those games with a tablet or with a mobile phone, right? Like, for example, here, perhaps my presentation right now is extremely boring, so you guys are also using your own second screen to give more value to my session. But anyway, sports is highly valued in the second screen applications. A last example I wanted to show you is the one from Netcore Sports. So what they do here is what the industry calls now media enrichment. So if you've been in the keynotes, in Andy Jesse's keynotes yesterday, he showed, the CDO of MBL showed how they enrich a video of a baseball game. They added information on the video stream. But this is not second screen, because you had the information on the TV. Here, this application is really second screen in a way that you're watching the game on your TV, as you can see here, right? But you have additional information on your tablet that you can control. So the point here is that you can watch the game from different angles. So you have live video streams, and you can choose the camera with the mobile application, and you're going to be able to replay yourself and to do replays of actions that you choose yourself. So that's really media enrichment, because basically they are adding value and they are adding data to a show, to this soccer game, and you are the editor, you are the one who is going to choose what are the actions you want to replay, see again from each angle, and so on. And now they do it also for other kinds of sports. So for motor race as well, here you can see that in this last screen on the right, you see the camera from inside the car. And in the application, you see here at the bottom the different cars. You can click on one of the cars and see the camera from each of those cars, right? So it's a pretty cool application, and technically it's pretty challenging, but you can summarize it like this. So you have an event source, which is either the soccer game or the car race. You're streaming two kinds of data flows. So you're streaming multiple video streams, so the cameras from each car, the cameras from each part of the soccer game. So you're uploading that to AWS, that then you're going to be able to restream it with for example, CloudFront. But at the same time, you're going to ingest game data, right? Like the GPS position of the cars, the position of the ball, and you're going to be able to absorb that, for example, with Amazon Kinesis. And your application is going to interleave those two informations, right? So you're going to have the live data stream of the GPS positions of the cars with the last examples that I show you with Kinesis. And you're going to have also the live video feeds that you're going to be able to broadcast with Amazon CloudFront. So those were a couple of examples that I wanted to show you to illustrate really what is second screen. And to give you the full story, please welcome Tiago from Magazine Luiza, who is going to explain how they built their own mobile application. Tiago.
Okay. Hello, everyone. My name is Thiago Catoto, aka Jesus. I work at Luiza Labs, which is our R&D department responsible for all the digital development of Magazine Luiza. I will talk a little bit about how we build a second screen experience by the time of the World Cup. Oh, sorry. So, a little bit of history here. Magazine isn't an actual magazine. It means warehouse in Portuguese, and we pronounce it Magazine. We are one of the top retailers in Brazil, with more than 700 stores, 8 distribution centers, more than 23 employees, and 36 million customers. We also have a very strong multi-channel strategy. So, by the time of the World Cup, we have a campaign running with basically two approaches. One that we send push notification, synced with the TV ad, when the message was based on the game score. The other was just to send users to our web app. So, Magazine has 2 apps published, and we decided to choose one of those to make this interaction. One that is our e-commerce app, and the other is a daily promotion app. And we choose the daily promotion app because users are already engaged with the brand. They are already used to receive push notifications daily, so we have more chance to interact with them by the time window that is short for 30 seconds to 1 minute that we run on the TV ad. We also believe that send custom messages based on the game score make it more personal, since we are trying to humanize our virtual seller that we call Lu. So, this is the timeline where we interact with the users. We choose 2 times to interact with them at the beginning of every game and on the halftime of the game when the TV ad was running on. We also send, before all that, we send a push notification to encourage users to update the app. This is how the app looks like. And we also make a customized skin for it to make the users more get into the spirit of the World Cup. And it worked very well. By the time we were struggling with a way to make the users get the most updated version of it. So this is the services that we use to make this kind of, put all of this together. On EC2 instances, we basically use C1 Medium, since they have them both available in the two zones that we use at São Paulo. For Elastic Cache, we use for cacheable objects and sessions, RDS with multi-AZ, SNS to send push notifications, and we start the implementation of the Cognito. That I will talk more about it later. So Magazine has two APIs. One that is the core API that serves all other platforms, and one that is the mobile API that only tends to mobile APIs. We choose that because we sense that we have to be faster on mobile. And there are some business rules that only make sense in the mobile world. So this is basically our structure. We have a load balance. It's pretty straightforward. EC2 instances with auto-scaling groups. RDS with multi-AZ. You can see that it's only pointed to one zone. The other is the fallback. And we have a split cached layer. We did that because we have experienced latency in the time when with Elasticast nodes, they get a little more latency, and all the instances of that zone start getting unhealthy as well. By doing this kind of approach, splitting in two cache nodes, we only lose half of the cacheable objects and half of the sessions. And even with a bad experience getting the user logged out, we don't lose the user's cart, since the core API that is responsible for all of it. We also use SNS to send push notifications to both of applications, mobile and Android, as I talked before. This is only the mobile API structure. The core API is way more complex, and it handles all the workflow of the cart, the user data, when he's buying a purchase or something like that. So let's move on. OK, on the SNS implementation, we start doing things wrong in the beginning. We had a loop going through all of the endpoints, and as the number of the devices grow, we have a slow send and a waste of CPU, since we are using EC2 instances to make all those push notifications. Here's the code that we use. You can see that it's kind of huge for sending one notification. And what we're doing is that we get batches of ending points. So we had to get a batch, see if there's another hop to make a next token, and then loop through all of the endpoints, which is basically a device, and send it one by one. Check it if it's enabled or not, and send it. It was such a waste. So later on, we start doing this with topics. With topics, we get a faster send and a better timing, because we get it synced with the TV ad. So this is the code snippet of the sending with push notification. You can see that it's way simpler, way faster. It's pretty straightforward. So a little bit of our Cognito roadmap. We want to make a wish list where we get all the synced with every platform. We do this because in the daily offer app that we have, people say, oh, I want to see the yesterday promotion. It wasn't there anymore. So that will encourage us to use it Cognito. We also want to make use of our own authentication. In doing so, we didn't have to handle all the synced and the merged between the products that is in the wish list, since Cognito handled it all for us. So we are able to make a web application integration with Cognito. We are using Python and use it in Boto to make this kind of integration. It was a little bit tricky for us because they didn't have all these points together, and we have to use unauthenticated versions of it. We also was able to make a Facebook integration in one of our apps and get it synced with the web app. So by the end of it, we learn a few things. And for this, you have to, timing is everything for the second screen experience. You have to be precise and interact with the user in the right time. And you also have to be prepared to grow fast, since we didn't have a lot of most time to prepare ourselves. So, for example, we changed the number of instances that we are going to grow on the Elastic Cache. Sorry, for the EC2 auto-scaling, we changed the number of instances to grow and lowered the time between the actions. In our case, we have to choose our target wisely, because we have 2 apps, and we didn't want to send the same message twice to our customer. And it worked very well for the app that we choose. So by doing that, we are able to get some final numbers. And this is that we're running the campaign. We have 35% more revenue, 53% more visits, and half of that was from new visitors. Well, that's all I have to say about it. Thank you very much for your time.
Thank you. Okay, so now with this story in mind and with the couple of examples that I presented earlier, I wanted to share with you a couple of best practices that I gather from other customers doing similar applications, doing second screen applications. The first one is, as Thiago mentioned, is the use of Cognito. This is really interesting because Cognito is going to have 2 features. First one is to obviously authenticate your users, right? If you have if you have in your application the need to screen your users and to identify them uniquely, which in most of the cases you want to do at least for ads or for user tracking. But the second one is to, via AWS STS, to give you credentials to access the AWS backend, right? And we're going to come back to that later because from a technical perspective, once you have an authentication token via Cognito, you can technically remove your front-end layer for the mobile application, right? So what we saw in the architecture from Magazine Luiza and from other applications is that you have a front layer of a load balancer and EC2 instances. But if your application is simple enough, you could have the mobile device directly writing to a database. What do you need a front end, right? If you have the AWS SDK and the token that allows you to authenticate yourself and write into DynamoDB. Because keep in mind that DynamoDB allows you to have the granularity down to the line, right? You can say that a user has access to a table in DynamoDB and only the lines that he created himself. So you cannot see the data of the other users. So it enables you to create very lightweight applications. The other point that is really interesting is that for mobile applications, roughly for 35% of the cases, the users are going to come first in the mobile application. They are going to download it when the TV show is going to start, right? Usually what happens is that at the beginning of the TV show, the application is promoted. Even sometimes, like what they did in Germany, you have a QR code at the beginning of the show, so you can scan your TV, download the application, and you don't want your users to lose time creating an account and entering 2 times the password and so on. So Cognito will be able to not only authenticate yourself either with your Amazon account or your Facebook or your Google Plus account, but depending on the application and depending on the game, sometimes users don't want to use their Facebook account or their Google Plus account. So Cognito allows you to have unauthenticated users, right? So people who come like guests, but still give them STS credentials so they can access the backend systems. And this is a really powerful feature because when you have your users coming into your application, they have to be able to use it very quickly. Because I mean, the the match is starting or the soccer game or the football game is starting, so they don't want to miss it and they don't want to lose time creating an account, right? Now, coming back to some of the challenges of those applications, the classic one is the scale and the reliability. Because this is something we often experience at Amazon when we do a Black Friday, for example. So Black Friday, we definitely know that we're going to have a huge amount of users compared to the traditional days. We don't know how many, but we're gonna have to scale way more. For second screen applications, it's exactly the same. It's even worse because when it's not in the time window of the TV show, you have absolutely no users. Typically, your application points to a static web page or a static image into Amazon S3, and that's it. When the game starts, you have to scale to probably 100 times or sometimes 2,000 times more the users you have usually on your application. And while doing this, you have to maintain reliability because obviously you don't want to lose any data, right? So first one regarding scale, something that is often overlooked is AWS auto scaling can allow you to have schedule scaling. That is, you can say at a specific point in time, add additional 200 instances, right? And when you see this feature, you can think of, well, the reason why I use auto-scaling is because I don't have to do capacity planning, so I'm going to add instances dynamically. But keep in mind that depending on your application, EC2 is going to be able to start an instance sometimes in less than a minute, but then your operating system has to boot. Then you have to perhaps deploy your software stack, execute your chef or your Puppet recipes and so on. So you can have an initialization time of your EC2 instance that goes sometimes between 5 and 8 minutes. And 5 and 8 minutes during a TV show, it's quite a lot, right? So you can send a couple of advertisements during this time window. So especially if you keep in mind that your total TV show sometimes will have a duration of between 2 and 4 hours. I mean, just take the amount of instances you had in the last show, double it, and you're fine. You know the prices of the EC2 instances. The prices are public. Don't underestimate the fact that you can put way more capacity because it's actually cheap to do it. It's actually very cost efficient because your TV show will have a very small span in time. So then it's not because you scale the front-end layer that you're safe. Obviously, the more instances you have, the more capacity you can absorb, the more pressure you're going to put in the backend and in the databases. So here, keep in mind that you can also very easily scale your backend. If you're using Amazon RDS, I mean, just do the, let's say, the simple and easy way. Just scale vertically your instance, even up to the biggest RDS instance size that you can have. Again, you're going to pay it for between 2 and 4 hours, so don't hesitate to scale as much as you can. Use read replicas, or do like what Thiago did for Magazine Luiza, use caching mechanisms to put objects in memory. And for DynamoDB, you can provision more capacity. So this is something that you definitely want to do before the TV show starts. A nice technique that has been promoted by Shazam in the last reInvent is a design pattern that involves using a queue in front of your database. So the situation for Shazam, so for those who don't know, Shazam is a mobile application that allows you to record sound, and depending on what you record, the audio that you record, you're going to have content that is going to be served to you. Like, for example, I'm recording a song, and they're going to send me the link on the iTunes store of where I can buy this song, right? The thing here is they promoted the application during the Super Bowl 2 years ago. And they managed to have something like 500,000 writes per second in DynamoDB. But in many situations, like the ones that you have in the Black Fridays, you don't want to lose data. Because obviously during a Black Friday, you're doing sales. For Magazine Louisa was exactly the same situation. People are buying during this period, so you don't want to lose data. But at the same time, you don't want to put too much pressure on your database. So one solution is absorb the request in a queue. SQS scales automatically and scales to very high volumes. And then you have in the other side, you have workers that are going to absorb the data from the other end of the queue and write it into the database. Because most of the time, when someone is buying on your e-commerce platform during a TV show, they don't mind being charged right now, right? I mean, the only thing you want to do is absorb the request, absorb the transaction from the user, and process it a little bit later, right? So this technique allows you to make sure that you're not losing data and you're not putting too much strain on the database. So the slides are still available. It was the session SVC 206 that you can find on the SlideShare account or on our website. But the most important thing is to test the application. I will never say it enough. I saw, unfortunately, a couple of cases of second screen applications that fail because they were not tested enough. The thing here is usually people who develop second screen applications are, I would say, well, traditional web ops or developers. But the thing that is fundamentally different in a second screen application is that during the show, when your application is live, basically you cannot do anything. That's it, it's done. It's too late to do any kind of change, any kind of operation, or you cannot push code. It's already too late. So you only have to sit and watch, that's it. Because usually you have like 30-minute time windows. You cannot deploy code during your production deployment of this kind of application. So the way to test it is to simulate activity, to do a real test situation. So there's a couple of techniques you can do. So my favorite one is pre-recording network activity. And this is a little bit like the VHS metaphor. So you record a TV show and then you replay it as many times as you want, right? And I remember when we've been working the architecture of Instagram 3-4 years ago, at some point, Justin Bieber created an account in Instagram, and a couple of minutes later, obviously the news spread around the internet, and everyone wanted to see the account. So they had a huge spike in traffic, which they survived. They were running on auto-scaling group. Everything was well configured and so on. But with the logs they had, they were able to replay what happened at this exact moment. So it's exactly as if they have like a small VHS tape of Justin Bieber joining Instagram in 2009, and then you can replay it for exercise or for demonstration purposes, right? So this is exactly what you want to do yourself. So you can do it pretty easily. You can front your load balancers during some production periods with a couple of instances running TCP dump. So TCP dump will load all the data into, for example, an EBS volume. Once it's done for a couple of hours, you snapshot the EBS volume, and that's it. You have your recorded done. So obviously, it requires more work to do it, but it's a very cool technique, because then you have TCP replay, which allows you to resend all the TCP traffic that you capture at that moment. And this will allow you to do load tests with real traffic, because you can also use load tests with the software that I'm mentioning here, for example, Apache Bench, Apache Gmeter, Locust.io, which is my favorite. You have the Grinder also for Java. By the way, Apache Gmeter, it's a little bit difficult to make it scale, because it uses RMI backend communication between the nodes. So use Apache Gmeter only if you want to stress test your database, but perhaps not that much for your front-end web applications. For the front-end web applications, either use the Grinder or Locust.io. They are already built with scripts that allow you to deploy the nodes that do the load test nicely on EC2 instances. And the downside of using software like this with generating requests is that it's not real traffic, right? It's automated traffic that, of course, is going to generate a lot of load. but it's not going to really test your application because anyone here who have been operating an application in real conditions can tell you that the only way you can absolutely validate your code is in the production environment, right? You can have 100% unit test coverage. You can run as many load tests automated like this as you want. But the thing is, in a production environment, you have real humans. And real humans sometimes are doing crazy stuff with your application. They are sending requests that you never thought people will do, right? Because you have your own, you built the application, you have your own logic, you know that people should go from this screen to this other and then the other one. But in reality, people come and they do whatever they want, right? So that's why recording traffic is a better technique because then you can replay all this kind of human strange behavior, right? But you can combine both. And actually, this is what another customer of us, Activision, did before the launch of their game, Call of Duty. This is a little bit off topic, but I wanted to illustrate this point for load testing. So here they have a massively multiplayer game. And the reason why they did load tests is obviously when you're playing those games, exactly like in a second screen applications, you don't want latency because otherwise the game is completely unplayable. Imagine if you're playing Who Wants to Be a Billionaire and you're receiving the questions with 5-minute delay compared to what you see on the screen. It would be completely ridiculous because you will have the answer, right? So you have to be completely in sync, exactly like for those games. Like if I shoot someone and 5 minutes later the player dies, I mean, it's completely unusable. So they use these C2 instances to simulate the load. And this is also important from a developer perspective because when you're a developer building those backends, generally the guys from the operation team are going to tell you, well, those endpoints, they have to give me an answer under 200, 100 milliseconds, right? So okay, that's the SLA or that's the constraint when you build your application. But now you're the developer, you're in front of your IDE or you're in front of your text editor, and how do you know that the change you're putting in the code is going to, how is it going to affect the response time? I mean, you can't know, right? It's impossible to know. There's so many different components that are involved in processing your request that the only way to absolutely know if your code behaves under the time constraints is to really test it, right? So that's what they did. And the reason why you want to test it is also because you want to find the break point. You want to understand when your application is going to break. That is, one EC2 instance of a certain type can sustain how many users, right? This is something that you absolutely have to know to fine-tune not only the scaling, but also to have an idea of how many users maximum you can sustain on your backend system. Another point on the tests and on automation is perhaps you saw sessions around infrastructure as code and automation. One of the best practices is also to deploy the backend system of your second screen application with a CloudFormation script. So for those who don't know, CloudFormation is a service that basically allows you to build from the ground up a complete architecture on AWS. So you have basically a text file that describes your architecture. That is a couple of databases, load balancer, front-end web servers, and so on. And you give the file to the CloudFormation endpoint, and it's going to create it for you. And this is definitely something you want to do because 1 hour before the shows start, you execute the CloudFormation script, the CloudFormation script, yeah, and your backend system is ready, up and running, right? But when you do that for production, you can also do it for tests, right? And the guys from Activision, for their game, what they were doing is every weekend they were recreating the production environment, right? And they were load testing it. And Monday morning, when you come back to the office, you have the results of the load test. And when you do that, you can also do what people did at Amazon or for the Obama campaign in 2012, what people call now game days. So the concept of game days is pretty straightforward, and this is something that has been widely used in many industries. For example, when you're an airplane pilot, when you're a pilot for the Airbus 300 series, you're going to go to the equivalent of a classroom, which is like the airplane simulator, and they are going to simulate a whole bunch of failures. So you're going to fly to the airplane, you're going to fly the airplane from Paris to New York, and during that flight in the simulator, they are going to put the engines on fire, they are going to simulate like one wing that doesn't respond, they are going to simulate that you don't have any fuel and so on. So they are going to simulate all sorts of failures. And this is exactly what you want to do yourself also for your team, right? Because one thing is to know that your application can sustain the load, but another thing is to be able to deal with everything that is unpredictable, right? And for the operation guys here, you know that life can sometimes be really, really unpredictable. That is, your database fails the day that you have the biggest show in the month, and the database administrator is at home sick because yesterday he was partying, right? So you want to test these kind of situations and see how your team can react. So you can do that in a test environment that you can create automatically with CloudFormation scripts. So before going to a Q&A, I wanted to share a couple of trends that I see in second screen applications. The first one is kind of an obvious extension of what exists today. It's everything related to attention analytics. So the classic case is we have an application in Germany which is media enrichment on soccer games, and basically they are looking for when people are using their mobile device or shaking the mobile device during the game, right? So if people use the mobile device during the game, it's because they are not paying attention. So it gives them an indication of how boring the game is or how boring a TV show is, right? So they can have this kind of attention metrics distributed on all the viewers. The other one is the second kind of applications that have been developed by VisiWare, which is a synchronization system for advertisement. So you're watching your football game with your application, and suddenly is the mid-period, you have advertisement. So the application works a little bit like Shazam. So it's constantly recording and looking at the audio stream with the microphones of the tablet. And when the application detects that there's an advertisement, so automatically it's going to push the advertisement on the application. So in this case, it's going to be an overlay. So it's a dynamic application of advertisement in the application, in the device itself. And some go to the extent of creating customized ads depending on the person, because what you can do on the web with banners, right, that is putting banners that are customized with the user because you are doing HTTP cookie tracking and so on, well, you can definitely do it with those applications, right? And one of the most exciting use cases I see is people that are using Amazon Upstream. So Upstream is our service for video generation and streaming, right? So it's used mostly for 3D video rendering and streaming of the video flow of the 3D rendering. So basically, they are filming a football game, and they are doing real-time incrustation of the ads on top of the field, depending on who is watching it, right? So they can put ads depending on what's your favorite team or your age and so on. But at the end, this is kind of the canonical architecture for the second screen applications. So it's a bit generalized, but you can also recognize the architecture of Magazine Luiza. So you have the client, the mobile device, who is going to receive the content via CloudFront, right? On the top, you see that you're going to receive push notifications via SNS. The authentication will be done via Cognito. The stream analysis of the data, you can use it with Kinesis. This is optional. Perhaps some of your applications, like in the case of Magazine Luiza, you don't have real-time stream analysis. But then EC2 will be your front end to collect the data and to interact with the mobile application itself. You can simplify the deployment by using Elastic Beanstalk instead of EC2. So you will have the load balancer included in the Beanstalk deployment. Then the data analysis can be done by Elastic MapReduce if you have log analysis or unstructured data. Most of the cases in those applications, you do have structured data because, I mean, at the end, you are controlling the application, right? So you can define what kind of data you're controlling. So you put it into DynamoDB, which then allows you to fine-tune the data and to give back the information to the mobile analytics platform that you see here at the end, which will give you more insights of who's using the application, how many devices deployed it, and so on. So with that, I wanted to conclude on this is the main reason why people are using AWS for second screen applications. As I mentioned at the beginning, the first one is the pay-as-you-go business model of AWS. That's kind of obvious, right? Again, if your backend architecture has to run just for a couple of hours, AWS has a great value proposition because you only pay by the hour. The scale and reliability, so that's not an understatement in these kind of applications. Your applications have to sustain a huge amount of scale. The automation services, we show that it's very useful not only for the tests, but also to prepare the deployment of the backend just before the show and to tear it down just after the show. And the last one, as we saw in this architecture, this breadth of services that allows you to focus on the application and not lose time on building a service for authentication, a service for SNS or for push notifications and so on. So with that, I think we still have 5 minutes. Yeah, 5 minutes if you have any question for me or Thiago. And I wanted to thank you for your attention, by the way. Cool, so no questions. So either it was extremely crystal clear. Oh no, one question.
Have you seen examples of people using, like, watching web streams on their mobile devices, then something else being the second screen, rather than TV as your first screen and then mobile devices?
Oh, so the question is, if we saw applications of people watching TV, watching another screen, or watching another video on the mobile device, and then like a third screen? Okay.
And we stream primarily on your mobile devices. We are not on TV at all. So we are thinking of building a second screen application to what we call the mobile device of your iPad or your laptop as a first screen. So have you seen examples of that?
Yeah, okay, okay, I get it. So the question is if we saw second screen applications for use cases where your main screen is a tablet or a mobile device. We didn't saw it particularly, but I think it's exactly the same concept. When we said that the first screen is a TV, it's because it's the classic use case today, but the first screen, let's say that it's the one that is static, the one where you cannot interact with it. And the reason why second screen applications exist is that because today a classic TV, you cannot go and change and interact with the TV itself. So I assume that if your first screen is already a computer or some kind of device that you can interact with, you may not need that much a second screen. But why not? Any other questions? Yes? What? Okay. So we'll go to the speaker lounge. Thank you all. Thanks.